On homework worksheet 5-1, number 1, what is the formula for the circumference C of the circle radius R? To find the circumference of the circle, that's the area, the region outside the circle, it's 2 times pi times R. Number 2, what is the formula for the area of a circle with radius R? Area of a circle is pi R squared. On 11 through 21, they wanted me to draw each angle. And this is what we covered on Friday in class when we talked about standard position. So for each one of these problems, we are going to need an X and a Y axis. So on number 13, I have an X here and a Y right here. Because it's a positive 135, I know that I'm going to swish my angle in a counterclockwise direction approximately 135 degrees. I know from the positive x-axis to the top is 90. I know the far left is 180 degrees. So 135 would be somewhere in quadrant 2. Okay. Let's go look at number 15. If you were to do number 15, again, you start the same way. I need an x-axis and a y-axis. My initial ray has to go on the positive x-axis. Because it's telling me to go 450 degrees positive, I'm going to swish this direction. I'm going to go more than 360. In fact, 450 minus 360 is 90. So I'm going to go all the way back up to here, and then I'm going to label it 450 degrees. On number 17, 19, and 21, we're doing the exact same thing, but this time we're thinking about radians. So the only one that might confuse you, I think, is number 19. So let's look at 19. On 19, I'm going to label my X. I'm going to label my Y. It's only different because it's got a negative. So because it's a negative, I'm going to make my swish go clockwise. And then I know that positive pi over 6 is located in quadrant 1, and it's really close to the x-axis. So I know negative pi over 6 is going to be located really close to the x-axis, that it's going to be in quadrant 4. So that's how you do this section here. On 35 through 45, they want me to convert. And they want me to convert from degrees to radians. Because they want me to convert to radians, each one of these is going to get multiplied by pi over 180. So I'll do a couple of these with you. If I were to do number 35, I'm going to have degrees times pi over 180. I'm going to put my 30 over 1. I'm going to go ahead and do some reducing here. So because I have them both ending in a 0, I can cross out the zeros. So now I have a 3 and an 18. I can divide both of those by 3. 3 goes into 3 once. So now I have a 1 up top here. 3 goes into 18, 6. So now I can multiply top times top and get pi, bottom times bottom, and get 6. My answer is pi over 6. Let's go do one of the negative problems. Let's go do number 39. Again, we're going to start off exactly the same way. I'm going to multiply by pi over 180. Put the 60 over 1. Same thing kind of happens. I've got a 0 and a 0. And then I have a 6 and an 18. What can I divide into 6 and 18? I can divide 6. 6 goes into negative 6, negative 1 times. 6 goes into 18 3 times. So top times top gives me negative pi. Bottom times bottom gives me 3. Okay. When we're doing the next section, 47 through 57, they want me to convert each angle in radians to degrees. So this time I'm going to go the opposite way. I'm going to change these pi answers to all be in degrees, which means I'm going to multiply by 180 over pi instead. So let's go look at 47. I'm going to put times 180 over pi. When I do that, I can see that my pi's are going to cancel out. And then my 3's, I know that 3 can go into 180. So 3 goes into 3 once, and 3 goes into 180. 60. So pi over 3 is the same as 60 degrees. Okay. Let's go look at number 53. So 53, we're going to start out the same way. I'm going to put 180 over pi. I'm going to see that my pi's cancel out again. Now, as I look at my 12 and my 18, as I look diagonal from the bottom to the top right, I can see that, wait a minute, these don't reduce all the way. But what can I divide into 12 and 180? Well, they're both even, so I could divide by 2, so I'll start with that. 12 divided by 2 is 6. 180 divided by 2 is 90. 6 is even, but 90 is not. And I told you after you tried even, go try the number 3. 3 goes into 6 and 3 goes into 90, so I can reduce again. So 3 goes into 6 2 times. 3 goes into 90 3 times. So we end up with 30 over 2. Well, 30 divided by 2 is 15 degrees. That answer is 15 degrees. At the bottom, on 71 through 77, the directions tell me that S is the length of an arc of a circle of radius r, subtended by the central angle theta. Find the missing quantity. So for each of these 4 problems, I have 2 formulas that I'm choosing from. If the problem is in radians, so if it's in radians, I'm going to use the arc length S equals the radius times my angle theta. If the problem is in degree, then I'm going to use the formula. The arc length equals r theta pi over 180. So these are the formulas that I have to choose from. If it's in radians, I use the top one. If it's in degrees, I use the bottom one. So on number 71, they want me to find S, and they give me my radius is 10 and my radian is 1/2. Because they give me theta as a radian, I'm going to use this first formula right here. So S equals R is 10, theta is 1/2, 10 times 1/2 equals 5, and the units they're using are meters. And that's it. It's that easy. You're going to plug in the same thing for 73, but this time we're solving for R. We're going to plug in again for 75, but we're solving for theta. We're going to plug in for 77, but on 77, it's in degrees, and we're going to solve for S. Okay, let's look at the back. On 79 through 85, for all 4 of these problems, I believe all 4 of them, it says A is the area of a sector of a circle of radius r formed by the central angle theta. Find the missing quantities. Okay, so if the theta is given in degrees, the formula we're going to use is area equals pi r squared theta divided by 360. If your theta is written in radians, we're going to use area equals r squared theta over 2. Or some of us prefer 1/2 r squared theta. These two formulas are exactly the same, just one is choosing to divide by 2, the other one is multiplying by 1/2. It doesn't matter which one you use, it's a preference that you get to decide on. Okay, so let's go look at number 79. On 79, they tell me my radius is 10 meters, my theta is 1/2 of a radian, find A. So they want me to find A, so here are my formula choices. They tell me my theta is a radian, so I have to choose between these two. My preference is to use the second equation when my radian is a fraction. So area equals 1/2, so I'm writing down my 1/2, r squared. Well, my r is 10, and 10 squared is 100, times theta, and my theta is 1/2. So I have a fraction times a whole number times a fraction. So what is 1/2 of 100? Well, 1/2 of 100 is 50. And now I'm going to do 1/2 of 50. So the whole thing is 25 meters squared. You're going to do the same thing for 81, 83, 85. Just pay attention to which formula you should use. And if you get stuck on one of these, you can ask about it in class tomorrow. On 87, they're asking you to find the arc length and the area. They give me theta as pi over 3, and they give me the radius as 2. All right, so I have to use the formula from the front down here, and we also have to use a formula from the back. So for the arc length, they tell me my theta is pi over 3. That's a radian, not a degree. So my arc length formula for radians was S equals R theta. So S equals the radius times theta. You're just going to go plug in, multiply, reduce. For your area in radians, I can choose between either of these two. Again, my theta is a fraction. Because it's a fraction, I prefer the second one. So 1/2 R squared theta. And you're just going to plug in and then reduce. 91, 93, and 95. I'm going to help you set up all three of these, but I'm going to let you actually finish and do the work. On 91, they tell me that the minute hand of a clock is 6 inches long. How far does the tip of the minute hand move in 15 minutes? Because they're asking for how far, to me, that means they're asking for a length. They're really asking me to find S. Okay? They're telling me the minute hand of a clock is 6 inches long. So I'm going to go draw myself a little picture over here. So here's my clock. And here's my minute hand. And it's 6 inches long. So now I can see that this really, that 6 inches, is my radius. And I want to know how far is it going to move if it goes 15 minutes. Well, if you look at your standard clock, 15 minutes is about 1/4 of your circle. So they're asking for this distance from 0 to 90 degrees, basically. So they're asking for the distance from 0 to 90 degrees. That means they gave me my theta. So my theta in here, we can choose to write it as 90 degrees. Or, if you prefer, you can write your theta as pi over 2. No matter which way you do it, we're going to get the same answer. The second part asks you to do something pretty similar, except it asks you to go 25 minutes. So you'll need to figure out, well, how much would 25 minutes be? Where would I be on my clock? And what would that be equivalent to as far as degrees go? Well, this was 15 minutes. So if I went 10 more minutes, so where would I be over here? And then again, you're going to use your arc length formula. So hopefully that helps get you started. Think about that. 93. On 93, they want me to find the area, that helps, of a sector of a circle with radius 4. So they give me the radius, and they give me the angle. So we're going to find area of a radius 4 with 45 degrees. They give me everything I need. All I have to do is go plug in to that formula. So I'll let you finish that. Okay, on number 95, A water sprinkler sprays water over a distance of 30 feet while rotating through an angle of 135 degrees. What area of the lawn receives the water? Okay, so they want me to find area, and they give it to me in degrees. So now I'm going to have area equals, I'm using this formula up here again, pi r squared theta divided by 360. So I have my theta, they gave it to me in the problem. I know pi is just pi, they gave me 360, so all I need now is my r. Well, let's think about one of those sprinklers that you have in your yard. So here's my yard, I know, pretty picture. Here's the little sprinkler that I put in the yard. And your sprinkler is spraying like this, and then it's going to go around some of those circular sprinklers. And how far do they tell me that the sprinkler could go out right here? It said it could go out 30 feet. So that means that's my radius. My radius is 30. My theta is 135. And now you should be able to go find the area. And remember I told you that we weren't going to do 97, 98, or 108. Okay, well I hope this helps you with your homework. Bring questions tomorrow. Remember this assignment is not due until Thursday.